Hey everyone, welcome back to my another DeepQ learning tutorial. So this time I'll talk about Epsilon Greedy strategies. In my previous tutorial, I said that in the next tutorial we'll try to implement prioritized experience replay method. But before doing that, I decided that we should cover Epsilon Greedy strategy method and fix or prepare the source code for our next tutorial method. So this will be a quite short tutorial, so don't worry. And I'll begin with that the Epsilon Greedy algorithm is a very simple and occurs in several areas of machine learning. One common use of Epsilon Greedy is the so-called multi-armed bandit problem. So let's take an example. I'll draw everything for us to be everything much more clear. So I'll use Pinta on my Linux. I'll open it. So let's take an example. Suppose we are standing in front of 3 slot machines. Each machine pays out according to a different probability distribution, and these distributions are known to us. And suppose we can play a total of 100 times. So we have 1, 2, and 3 machines. We have 2 goals here. The first goal is to experiment with a few coins to try and determine which machine pays out the best. The second goal is to get as much money as possible. The term explore and exploit are used to indicate that we have to use some coins to explore to find the best machine, and we want to use as many coins as possible on the best machine to exploit our knowledge. So Epsilon Greedy almost too simple. As we play the machines, we keep track of the average payout of each machine. Then we select the machine with the highest current average payout with probability of 8%, for example. And we select machines that don't have the highest current payout average with probability 20%, for example. So it's much easier to understand with concrete example. Suppose after our first 12 pulls we played machine 1 4 times and we won $1 2 times, so we can write it out. We played, for example, 2 times and we won $1, and we played more 2 times and we won 0, or we lost both times. So we'll draw a 0 here. The average win rate for this machine is 0.5. That's right. And suppose we played machine 2 5 times and won $1 3 times and $0 2 times. So I can write it something like $3 and 2 times nothing. Sorry for my drawing, it's horrible, but it is how it is. And the average payout for this machine will be 0.6, just like that. And suppose we played machine 3 times and won $1 1 time and $0 2 times. So 1x1 will be, and 2x0. And here I can write that average payout for this machine is 0.33. Yep, that's right. Now we have to select the machine to play, or we generate a random number p between 0 and 100, for example. Suppose we have set epsilon equal to, for example, 90%. If random number is lower than 90, which will be 90% of the time, we select machine 2 because it has the highest average payout. But number higher than 90, which it will be only 10% of the time, we select a random machine. So each machine has a chance of being select 1 from 3. So shortly talking, we all the time play on this machine, and 10% of times we choose randomly which machine we want to play. And notice that machine 2 might get picked anyway because we select randomly from all machines. Over time, the best machine will be played more and more often because it will pay out more often. In short, Epsilon Greedy means pick the current best option. I mean greedy most of the time. But pick a random option with a small probability sometimes. There are many other algorithms for the multi-arm bandit problem, but Epsilon Greedy is incredibly simple and often works as well as or even better than more sophisticated algorithms such as upper confidence bound variations. The idea is that in the beginning we'll use Epsilon Greedy strategy, and what we do, we specify an exploration rate epsilon, which we set to 1 in the beginning. So I can open your drawing, and yeah, I can maximize it, something like that. So we set 1 in the beginning. This is the rate of the steps that we'll do randomly. In the beginning, this rate must be at its highest value because we don't know anything about the value in Q table. This means we need to do a lot of exploration by randomly choosing our actions. So we generate a random number. If this number is more than epsilon, then we will do exploitation. This means we use that we already know to select the best action at each step. Else we'll do exploitation. So as you can see, here is our exploration and exploitation, and for example here is our epsilon, and it depends what we'll do of what random number we get. It's higher than epsilon rate or lower than epsilon rate. The idea is that we must have a big epsilon at the beginning of the training of the Q function, then reduce it progressively as the agent becomes more confident at estimating Q values. So now we can go to the code as I showed this to you already. I'll copy my third tutorial code here. I can rename it to something like, right now it will be D3QN, and here will be Epsilon Greedy strategy, something like that. Oh shit, I need to rename it again. Double and Epsilon Greedy rename, and let's open it with our Sublime editor and so on, and we can begin somewhere. We'll keep almost all the same code, so you might ask what I changed in this code. Actually, it almost didn't change, so I simply inserted self epsilon greedy true here, not here, here I should insert. So self.epsilon greedy will be equal to true. Epsilon, yeah, that's right. And epsilon decide, I'll change it here from, before it was 999, but in this tutorial I'll change this, so it will be simply 0.005. So this will be my epsilon, new epsilon decide rate. We won't use train start anymore, so I can remove this. What I'll change more. So why I choose to insert this is the Boolean option if we want to use this method or not. So exploration hyperparameters for epsilon and epsilon greedy strategy will be quite the same. So what I change here, I won't use this anymore. This double or not double, it doesn't matter. So I'll just remove this and this, and right now it will be simply a self-model name, and here I'll use not dwelling anymore, but maybe self-set path, the same as before, and self-environment name, I'll choose this, self-environment plus was before at the end, but we don't need this at the end, so I'll use like that, and here I'll add a greedy, just like that. And yeah, at this place, that's it. We can move to our remember function. So from our previous tutorial, we had this remember function. Right now I'll change this a little bit. So right now it will have something like experience, and it will be equal to these parameters. Experience will be equal. And now what I'll do, that I always self.memory.append will be experience, just like that. So now what mostly changes is our act function. So before we are checking if our memory list is equal to self-train start. From now on we'll do training from our first episode of the game. We won't fill memory with samples, so we are removing all lines and will implement the Epsilon Greedy function in different places. So until now we were having only this. So right now I'll just a little change everything. So now here we'll use a decide step, epsilon decide. Before we were not using this. So now if self.epsilon greedy equal to true, so if we choose this, we do this, else we use standard epsilon function as before. So we'll begin from here. So I'll write here exploration probability, exploration or explore. All right, explore, maybe explore probability, and it will be equal to self.epsilon min plus self epsilon minus self epsilon min, just like that, and we'll multiply it by numpy exponential, and here will be our minus self epsilon psi multiplied by psi step psi. Where is our epsilon psi step? So yeah, it should be here, epsilon psi. So epsilon psi decide step, because epsilon decide we have on the top here. Yeah, that's right. So now this is only our epsilon greedy strategy, and now we would like to return to our previous strategy, for example. So here we just measure if self epsilon is more than self epsilon min. It's like that, epsilon min, and if it is, then we do a self epsilon multiplied by 1 minus self epsilon psi. So 1 minus self dot epsilon psi, just like that. And here our explore probability will be equal to self epsilon, like that. Now if exploration probability is more than random, so something like this. So maybe I can choose this. So if explore probability is more than our epsilon, no, I think it's wrong here. So I should have used random. So I'll choose the same numpy random, sorry, rand, and yeah, if just like that, we'll return a random rand range as it is here, but instead of action size, we actually will add explore probability. So we want to return this, and otherwise we also return explore probability here. And yeah, I think we can minimize this, and yeah, we need to add one more tab here. So else, or no, I was wrong, we don't need tab here. So that's the idea. And yeah, I think I finished the act function, which changed the mostly. So in all code, I am removing the self-length memory function. So for example, if I can try find if length self memory train start, something like this. I think we don't have, we have it. Actually, yeah, we have it only here. So I'll removing this in my replay function. And yeah, that's it in what we change in our replay function. I can yeah, I almost forgot this. I'm adding here additional self epsilon greedy. So if self epsilon greedy, we write something like that our greedy is equal to probably greedy, just like that. And here I actually add this as greedy, and I should not forget to add it here, greedy. So that's it. And now what's left is to change few steps here in our run function. So here I use a decide step is equal to 0 at the beginning, and here I'll add a decide step, I think. So yeah, decide step is equal +1, and here where I am doing my step environment act, I mean, where's my act? Here, action, yeah, here is my action, and I here add a decide step that I'm sending it to my action function, and here I'll add an explore probability actually, and I think that's it. What I'm more changing is my print in episodes. So here I have a episode score, epsilon, and average. So right now I'll change this. So I should add explore probability. So instead of epsilon, so I don't need epsilon here. Explore probability I'll add here. So everything should be quite fine here, but let me think one time. Average, epsilon. Yeah, I think everything is set here. I think I can save it, and of course we can try to train our model probably. Okay, I'll just run it, and I'll check if we have any errors here. So yeah, we have something. If explore probability is here, what was the error? I didn't read it. Inconsistent use of tabs. Okay. Yeah, this problem occurs usually on when I use Sublime. So I hate this. and I don't know usually how to fix this. But yeah, I see that. So I've fixed the indentions, sorry for them, and sometimes, yeah, I face these problems, but yeah, that is the cost of this Sublime editor. But in most cases, everything is fine. Just now I face this, so we can actually try to train our model. I build this, and that's it. As you can see, it keeps training. It will train for 1000 steps and so on, but I don't want to wait for it to finish, so I will simply stop recording, right, and I will come back when it's finished, or simply I'll show you the results. So okay, for now I'll stop recording. So I've finished training the model, and here is the results of Epsilon Greedy strategy playing for 1000 steps on card pull game. So it's nothing a lot what to tell about this strategy. It's very similar to my previous tutorial strategy. I won't do a comparison how our agent performs with Epsilon Greedy and without Greedy, because before we were using a very similar strategy to reduce Epsilon, so there won't be a significant difference. But for your interest, here is the results, how Epsilon Greedy performs. And I would like to tell that in this short tutorial we simply prepared our code for coming tutorial, where we'll implement or integrate priority experience replay method for our agent. With this method our agent should improve significantly, so keep watching, and it should be quite soon, probably next week. So thank you all for watching. I hope this tutorial was useful for you and you'll use it, you'll share it, you like it, and so on. So thank you all for watching, good luck, and see you in our next tutorial. Goodbye.